In this video segment, we're going to talk about the last two of the Jovian planets, which are Uranus and Neptune. And yes, folks, that is how you pronounce the planet's name. Unlike when we were kids and we were told, aha, it's Uranus, it is not pronounced that way anymore. The official astronomical pronunciation is Uranus. We're also going to talk about some Kuiper Belt objects as well as the dwarf planets. Okay, so let's talk about Uranus and Neptune together. They are very much alike in that they look very similar. So whereas the Earth and Venus are called the sister planet, or Venus is called our sister planet, Uranus and Neptune are also twin-like. Uranus's density is a little bit less than Neptune's. It's only 1290, whereas the density of Neptune is about 1660. Uranus is about 4 times that of the Earth, 4 times the size of the Earth, whereas Neptune's only 3.9 times the size. But notice the mass difference. Whereas Uranus is 14.5 times the mass of the Earth, Neptune is much more massive with 17 times the mass of the Earth, and that's what gives it that higher density. Uranus does have a period of 17 hours and 14 minutes. This is very similar to Neptune's period, which is 16 hours and 3 minutes. Both planets have differential rotation. However, Uranus also appears to have differential rotation rate for the inner part of the planet that's different than the outer part of the planet. So it actually rotates differently inside as well as at the poles. Another unique characteristic of Uranus is that it has a rotation axis that's tilted 97 degrees 55 minutes. And that, compared to the 28 degrees for Neptune, puts Uranus on its side. It's believed that probably when Uranus was forming, there was some type of collision with an asteroid or another planetesimal that caused this planet to actually flip onto its side. And again, like it was stated in the previous video with Jupiter and Saturn, both Uranus and Neptune do have ring systems. Uranus's ring system is 9 thin rings. They're very dark and narrow, but widely spaced. Neptune has 4 rings, and the only way to see them is to actually have a block and to amplify the light coming from the ring system. Now, the one thing that I love about these two planets is their color. They actually are blue planets, and it has to do with the methane content. Uranus has a methane percentage of about 2%, and Neptune is between 2 and 3%, and that's what gives it that beautiful blue color. I would venture to say that the percentage of methane on Neptune should be higher than the 2%. That's why I put 2 to 3%, mainly because it's actually a deeper blue color. Also, when it comes to storms, Neptune does appear to have a more active surface than Uranus. I'm not sure why that is, but Uranus doesn't appear to have much atmospheric activity taking place. So let's talk about the 5 largest moons of Uranus. Here they are. It's Oberon, Titania, Umbriel, Ariel, and Miranda. So those are the 5 largest moons of Uranus. For Neptune, the most interesting moon is the largest moon of the planet, which is called Triton. It mainly has a nitrogen atmosphere. It also has these large fissures and these lakes of ice. It also has a retrograde orbit, meaning it's going clockwise instead of counterclockwise. And it appears that it's going to move slowly into the Roche limit within 100,000 years. Once it moves within the Roche limit, the planet itself is going to start pulling apart this moon, and eventually what's going to happen is that this moon is going to feed into that ring system, making it much more impressive. In fact, probably just as impressive as Saturn's ring system. So if we're here in 100,000 years or longer, we can start to look forward to having a huge ring system of Neptune. Okay, so now we're going to talk about the dwarf planets. This is a new category that came about because of the group, the Michael Brown group, that discovered quite a few objects beyond Neptune. And because of that, they had to actually come up with a definition of planet. And we covered that in the last unit when we talked about all of the planets in general, the solar system in general. So now we're going to talk about these dwarf planets in a little bit more detail. Okay, Pluto has a density of about 2,050 kilograms per meter cubed. That puts it at the low end of rock. It's believed it's probably got some methane and some icy surface. It could be solid underneath. We're not really sure. It's very small. It's only 18% the radius of the Earth. And notice the mass is much, much lower. It's 2 times 10 to the minus 3 times the mass of the Earth. It does have a tilt of 122.5 degrees, and that means that it's rotating clockwise instead of counterclockwise. Again, this could be due to an impact with another object. Its axis is also tilted 17 degrees with respect to all the other planets. And so that gives it quite a bit of a tilt compared to the solar system itself. We see that a lot when we start looking at these objects that are in the Kuiper belt. Okay, so we also call this a trans-Neptunian object, or a TNO, and that's because this planet crosses the orbit of another planet. Okay, there are at least 5 moons as of 2006. Charon, which is, we believe it could be probably Pluto and Charon are probably a binary system. The moon is very, very large, and it could be that both of these are moving around each other, a central location, instead of Charon moving around Pluto. We also have Nix, Kerberos, Styx, and Hydra. Notice the theme here. These are all creatures of the underworld, or the river Styx. Okay, Sirius is the next one we're going to talk about. This is actually in the asteroid belt. It has a diameter of about 945 kilometers. Its density is about 2160, which tells us it's a little bit more rocky. It's composed of rock and ice, and it appears to have a rocky core. It does appear to have water ice below its mantle. Or I'm sorry, in the mantle below its crust. Eris is further away from Pluto, but it's actually larger. It was actually discovered in 2005 by the team led by Michael Brown. It has a diameter of about 2,326 kilometers and a density of about 2,500. Notice that this density is a little bit higher than that of Pluto. It's located at 96.3 astronomical units away, very, very far. It's also a TNO, a trans-Neptunian object, so eventually it will cross the path of Neptune. If you take a look at this diagram, I'm going to let you stare at it for a little bit. You can actually see how they discovered Eris. Basically, they took pictures of the sky, and then what they did was they overlapped these pictures in order to make this movie. And by looking at the overlap, they were able to see an object moving. If you look at those lines, those dark lines that appear to be moving from the upper right-hand corner down, those are called fringes. And that's caused by the photograph light adding together constructively and destructively. So when it adds together, it forms these bright and dark lines. It's actually kind of cool. So you can actually see the fringes forming by the overlapping that they did. Okay, if you haven't seen it yet, I'm going to give you a hint. It's on the left-hand side. So it's over here somewhere. Okay, so hopefully you saw it. It is right here. And you can see that it's actually moving down on the screen. So by looking at multiple nights, taking photographs of this, seeing how far it moves, they can figure out how fast it's going. And from there, they can figure out its location. And then they can figure out also the time period, and that also gives us the distance. Okay, the next moon, I'm sorry, not moon, the next dwarf planet we're going to talk about is Makemake. It has a diameter of 725 kilometers. Its density is about 3,000 kilograms per meter cubed. That makes it more rock than ice. It does have one moon, and again, it was discovered by Michael Brown's team in 2005. It is only located 45 astronomical units away, so it's actually closer than Eris. But because of its size, it was much more difficult to find. It is again a trans-Neptunian object, and that tells us that it will eventually cross the orbit of Neptune. Haumea has a diameter of about 650 kilometers. Its density is about 2,600 kilograms per meter cubed. That again puts it in the low end of rock, so it's probably bits and pieces of rock and ice. It does appear to have two moons, and this one was discovered in 2004. It's located 43 astronomical units away, and it is also believed to be a trans-Neptunian object. Haumea actually has a shape that's actually not spherical. And remember that that was one of the requirements of being a planet. But what they found out was that when they looked at this and they looked at its rotation rate, the rotation rate is so high, it's actually causing this planet to actually spread out. So it's sort of like watching somebody spinning around. When they put, it's really hard to just stay stationary. Usually what happens is like your clothes will fan out, or if you're wearing a skirt and you spin around, that skirt will flow outward. That's exactly what Haumea is doing. Because it's rotating so quickly, it's actually spreading out its material as it rotates. Okay, now there's two other objects I want to talk about, and these are actually KBOs, although all of the objects we've talked about from Pluto on are minus Ceres are all KBOs. They're all in the Kuiper belt. But these are not classified as planets. There's Quaoar, which is in the Kuiper belt. It's 800 miles in diameter, and Sedna, which we believe to be in the Oort cloud. But again, remember that Oort cloud hasn't really been discovered yet. And this appears to be about 800 to 1,100 miles in diameter. So these are very small objects. They're not going to be spherical in shape, and that's why they're called Kuiper belt objects and not dwarf planets.